This exercise will assess three teachers, Smith, Jones, and Brown, who teach high school science. At the end of a unit, students take a standardized test on the topic. Considering the number of periods missed year to date, is there a significant difference in the scores of students taught by Smith, Jones, and Brown? If so, where does the difference occur? The null hypothesis states that there is no significant difference in scores between the three classes when controlling for the number of periods missed. The alternative hypothesis states that there is a significant difference in scores between the three classes when controlling for the number of periods missed. Here we have our data. First, I will check for the homogeneity of regression slopes. Go to Analyze, General Linear Model, and Univariate. Highlight the class and move that over to the fixed factor box. Highlight test and move that over into the dependent variable box. And highlight the periods missed and move that over as the covariant. Select Model and Build Terms. We'll move the variables over and create an interaction between class and missed periods. Select Continue and click OK. Looking at the output at the class times the missed period results, we have a significant value of 0.488. Since P is greater than 0.05, the homogeneity of regression slopes is met. I will proceed with the ANCOVA and check for homogeneity of variance. So we'll go to Analyze, General Linear Model, and Univariate. Our variables are still where we place them, so we'll select Model and change that back to full factorial. Click Continue. Select EM means for estimated margins. Highlight class and move that over into the display means for box. Check the box for compare main effects. Select the drop down. Select Bonferroni. Click Continue. Click on Options. Select Estimates for effect size and homogeneity tests. Then click Continue and click OK. And here we have our output. Looking at the Levene's test of homogeneity, it shows a significant value of 0.691, which is greater than 0.05, therefore equal variances are assumed. Looking at the test of between subject effects, the class has a significant value of 0.02. Since P is less than 0.05, there is a significant difference in test scores. Eta squared equals 0.09, which indicates a moderate effect. We'll scroll down and look at the adjusted means. Here for Smith, we have 84.1 with a standard error of 1.12. For Jones, we have a mean of 79.93 with a standard error of 1.11. And for Brown, we have a mean of 80.47 with a standard error of 1.12. And now we'll take a look at the pairwise comparisons. Here we see that Smith and Jones has a significant value of 0.029, which is less than 0.05. So therefore, there is a significance. Between Smith and Brown, the significant value is 0.075, which is greater than 0.05, and there is no significance. And then we look at Jones to Brown, which has a significant value of 1, which is greater than 0.05, and there is no significant difference. So for APA reporting, an ANCOVA was used to examine whether standardized test scores differed significantly among 3 science classes, controlling for missed periods. Data were collected for 30 students. Preliminary checks were conducted to assess the assumptions of homogeneity of regression slopes and homogeneity of variance. Results indicated that the homogeneity of regression slopes was met. F with 2 and 84 degrees of freedom equal 0.72, where P equals 0.488. Levine's test indicated that homogeneity of variance was assumed. F with 2 and 87 degrees of freedom equal 0.371, P equals 0.691. There is a statistically significant difference in scores among the 3 classes when controlling for the number of periods missed. F with 2 and 86 degrees of freedom equal 4.12, P equals 0.02, eta squared equals 0.09. Estimated marginal means were significantly different between Smith with a mean of 84.1 and a standard error equals 1.12, Jones with a mean of 79.93 and a standard error of 1.11, and Brown with a mean of 80.47 and a standard error equals 1.12. The pairwise comparisons indicated a significant difference in scores between Smith and Jones, where P equals 0.029. There was no significant difference in scores between Smith and Brown, where P equals 0.075, and Jones and Brown, where P equals 1. The moderate effect of eta squared equals 0.09 suggests that the class accounts for 9% of the variance in test scores after controlling for missed periods. Based on this outcome, Smith had fewer missed periods than Jones and Brown, resulting in higher test scores. Therefore, we reject the null hypothesis and conclude that there is a significant difference in scores among the 3 classes when controlling for the number of periods missed. And that concludes this analysis.